Hello everyone, this is Mr. of Help, and we're going to look at another example of graphing using transformations. First again, to identify the parent function, this one is the x part is being raised to the second power, so that's our quadratic parent function. So our parent function is y equals, or k of x equals x squared. We're going to make our table of x's and y's for our quadratic. We have negative 2 squared is 2, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4, which brings me back to that first one. Just making sure you were paying attention, that was actually a 4. Okay, now we're going to identify the transformations. Now this sometimes confuses people because they don't see the parentheses, so I thought I'd throw an example like this in there. You could think of that x squared as being just an x minus 0 squared, if that's helpful. I hope you can see that this is the same as, these two things are the same, that x minus 0 squared is just x squared, and so when written like that, the parentheses really are unnecessary. I mean, if you were to write this with those parentheses in there, because that helps you, it's not the end of the world, but again, it's not necessary, so best to leave them out. Okay, so what that means is there's no left or right translation. We do have the negative 1/2, so that's an x-axis reflection. And it's also the 1/2 is going to be a vertical compression by a half. And the +3, oh, I wrote +2 over here, that was a 3. The +3 means it's going up 3. So all of these are applying to the y. It's after the x has been squared, then we multiply, then we add, right? All of these transformations are affecting the y values and not the x values, right? In x-axis reflection, you may remember the x values stay the same, the y values change sign. If you remember that from your geometry transformations. The compression is a vertical change, so that's affecting the y up there. So anyway, all of these transformations are affecting the y values, so the x values actually just stay the same. The y values are getting multiplied by the negative 1/2, and then after that we're adding 3. So the x values I'm just going to copy because they didn't change at all. And now for the negative 1/2 times 4 is negative 2. Negative 2 plus 3 is 1. If you can do that in your head, go for it. For y equals 1, that's negative 1/2 times 1 is negative 1/2, plus the 3, that's 2.5. When y is 0, that's 0 plus 3, which is 3. 1 gives us the 2.5. It's the same as the one I just did here, so right, those y values are already the same, so these are obviously going to be the same. Same thing for these two. The y value is 4, the new y value is 1, so I get that over again. Okay, so I'm going to go ahead and plot those. So negative 2, 1 is right there. Negative 1, comma 2.5 is right there. 0, 3, 1, 2.5, and 2, 1. And now hopefully that's enough for you to see what's going on here, to see that it's that quadratic. It's reflected, so it's upside down. It's moved up 3, and it's a little fatter than usual. It's a little wider because it's been vertically compressed. If you feel like you need a couple extra critical points, it can't hurt to add them. So you could go back to your original xy and do the 3. So negative 3 squared is 9, and positive 3 squared is 9. And then for our negative 3 and positive 3, we're a little out of order here, but it doesn't really matter. Negative 1/2 times negative 3 would give us a positive 1.5, plus the 3 gives us a positive 4.5. Did I do that right? I think I did. Oh wait, what am I doing here? I put the wrong value in. Oh boy. Let's back that up again. Sorry. Totally lost myself here. So when x is negative 3, the y is 9. So the 9 is your y value. So negative 1/2 times 9 is negative 4.5. And negative 4.5 plus 3 is negative 1 1/2. And I'm going to get the same thing here because the y value was the same, negative 1.5. And by the way, if I had that mistake I just made, which as you see can happen to anyone, even someone like me who never makes mistakes, what was that? What was it I had before? I had like 3, and I can't even remember now what it was, but that y value would have been like up here somewhere. So if you do that, again, it can happen to anyone, but don't just leave it there. Clearly that point would have been wrong, and then you could go back and try to double check your work. Making mistakes is fine, and not doing anything about it and fixing it, that's a problem. Okay, back to business. So negative 3, negative 1.5 puts me here. Positive 3, negative 1.5 puts me here. And if that's helpful to get just an extra couple of aiming points for your parabola, you can do that. But if you can make a decent sketch without it, that's fine too. And that's all for now. Thanks.